Hello everyone and welcome back to the Doc Vile A-Level Chemistry YouTube revision channel. This channel is all about getting you ready for your A-Level Chemistry exams. And this particular video is going to focus on naming and drawing alkenes. Now, you may have found it helpful if you've watched the previous video, which is all about naming and drawing alkanes, because I'm going to assume a little bit of knowledge from that video. Such as the prefixes me, fef, prop, but, pent, etc. So if you haven't, you might want to pause, go watch that video, then come back, but not essential. Not essential. Okay, so starting off with the simplest possible alkene. Well, what do we mean by an alkene? The key difference between an alkene and an alkane, and I'm not going to go into the bonding in much detail in this video, more just the drawing, is that there is a double bond between the carbon atoms as opposed to an alkane where there is a single bond. So eth means that there are two carbons and ene refers to the fact it's a double bond. Now carbon always makes four bonds, so there needs to be four lines coming out of each carbon, and then this bonds to hydrogen. So the displayed formula for ethene will be as shown on the screen. The molecular formula will be C2H4, two carbons, four hydrogens. The empirical formula, so this is the molecular formula, the empirical formula would be CH2. We can divide them both by 2. Remember, the empirical formula is simply the simplest ratio between the atoms. And then the skeletal formula, we treat it as a zigzag. So you've got two carbons, so 2 points on the zigzag, so it's just a diagonal line. But because it's a double bond, it looks like a weird equals sign. So just to recap, this is called the displayed formula, DF, where you show all the bonds. The molecular formula is where you count the atoms. The empirical formula is the simplest ratio of the atoms, and then the skeletal formula is basically the carbon backbone with any interesting functional groups on it. So that's ethene. Now when we get to propene, prop means three and ene means there's a double bond. So you go 1, 2, 3, and you have to put a double bond either to the left or the right. It doesn't actually matter when there's only 3 carbon atoms. It will give you the same molecule. So let's just put it to the left, and then a single bond to the right. So we're only talking about one double bond in this video. I'm not going to go into anything more complicated than that. So just one double bond. And then you have to go through and apply the golden rule that carbon makes 4 bonds. So this carbon on the left is currently making 2, so it needs 2 more. This middle carbon is currently making 2 to the left and 1 to the right, so it needs 1 more. And then this carbon at the end needs 3 more to be making 4. So that would be the displayed formula of propene. So the molecular formula would be C3H6. And the empirical formula, you can divide both these by 3, so that would be CH2. And for the skeletal formula, you draw out the skeletal formula of propane, which is a zigzag with 3 points, and you make one of the lines into a double line, like this. And it's worth noting that for alkenes, for every n carbons, where n is just a number, you have twice as many hydrogens, so it would be 2n. For an alkane, it was 2n plus 2, so it's a little bit different. So things are relatively straightforward when we just look at ethene and propene, and they get a little bit more complicated when we get to butene, which we'll see on the next slide. Okay, so with butene, but means 4 and ene means there's a double bond. So let's just put your 4 carbon atoms here, 1, 2, 3, 4. And I'm going to put them here, 1, 2, 3, 4. Now the first possibility is to put the double bond at the end like this, and then these are single bonds. and put the remaining hydrogens on like so. And we call this but-1-ene. Now we have to number where the double bond is. And the reason we have to do that is because there's more than one possibility as to the position of the double bond. It could be in the number 1 position, i.e. starting at carbon number 1. So if these are 1, 2, 3, 4. Or, as we're going to see, it could be starting at number 2. So we call this one but-1-ene. But the other possibility is that it starts on carbon number 2, like this. In which case we'll call it but-2-ene. However, there's a little bit more to it than this. I want to show you why. If I can just get rid of this and tidy up my diagram a second. The double bond always has this bond angle of 120 degrees. Now you've got a carbon on either side of the double bond like this. Now it's possible to have them on the same side of the double bond, as so. So that would be CH3 groups, also CH3 groups. And it's possible to have them on opposite sides of the double bond. So you'd have the CH3 going up on one side and the CH3 going down on this side. So if you look carefully at this, they have different geometries. You have the same bonds, but they are in different geometries. So we call these geometric isomers. And how is this possible? Because this doesn't happen with alkanes. Well, with alkanes, the single bonds are constantly rotating, in which case the orientation of the bonds doesn't really matter in terms of how you draw it. However, when you have the double bond locks the molecule into place. It restricts rotation, which means that the geometry is locked. And therefore you can get these geometric isomers. So there's some conditions required for geometric isomers. You have to have a double bond, as opposed to a single bond, and you have to have 2 different groups on each side of the double bond. Now we need to be able to add some assignment to this. So how do we name this top one compared to the bottom one? Well, to do this, we have to prioritize the groups on the double bond. So you firstly imagine there's like an imaginary line going down the middle, and you look at the left-hand side first, and you prioritize the groups based on atomic number. So hydrogen versus carbon, and you'd say, right, carbon is higher than hydrogen in terms of atomic number, therefore the carbon has the high priority and the hydrogen has the low priority. And then you go to this side, the right hand side, and you say once again carbon has the high priority, hydrogen has the low priority. And as the 2 high priority groups are on the same side, we call this the Z isomer, sometimes referred to as the cis isomer. And if you want an easy way to remember about this, you've got to say it with a German accent. You've got to go, they are on the same side. On the same side, the Z isomer. And then you go down to the one at the bottom and you say carbon's high priority, hydrogen's low priority, carbon's high priority, hydrogen's low priority. This time, the high priority groups are on opposite sides of the double bond. And therefore, this is the E isomer. And a way to remember that is E for enemies. Enemies keep away from each other. This is sometimes referred to as the trans isomer. So when it comes to butene, you have a variety of different isomers. You've got but-1-ene and but-2-ene. These are what we call structural isomers of each other, as in they have a completely different connection of the bonds. But then you have geometric isomers for but-2-ene. And this is where you have the same bonds but different geometries. And you'll always have geometric isomers where you have a double bond with different groups on each side of the double bond. and you have to assign priorities based on atomic number. Let's look at another example. For pentene, the first possibility, same as what we saw for butene, is that you've got your 5 carbon atoms, 1, 2, 3, 4, 5, and you put the double bond at the end, like this. Then you'd have your hydrogens, 2 on this end, 1 on this end, and then these are all single bonds, and then we add the hydrogens. Now, pent-1ene, as it's called, doesn't have EZ isomers, and the reason being these two groups on this side of the double bond are the same, and you have to have different groups on either side of the double bond in order to have EZ isomers. So pent-1ene is going to be a structural isomer of pent-2ene, and there's going to be 2 different isomers of pent-2ene. I always try to put the double bond fairly central when I show this. I think it helps. And then coming off this one here, you're going to have a CH3 group and a hydrogen, and then a CH2, CH3. I'm kind of blurring my types of structures here just to make it easy to see, and then a hydrogen this way. And we would call this one Z pent 2ene. So the 2 is referring to the fact that the double bond starts on carbon number 2, and the Z is referring to the fact that this is the Z geometric isomer. The high priority groups are on the same side. And then I can draw it again, where you've got the CH3 going down, but the CH2, CH3 going up like this. CH3 is the high priority group on the left hand side, CH2, CH3 is the high priority group on the right hand side. These are enemies of each other because they're keeping away from each other, so this is the E isomer. And remember, E is sometimes referred to as trans being different, whereas Z is the cis. Let's look at a few more examples just to check that you've got this. So on the screen at the moment, there are 4 different structures. If you think you've got it, press pause and check if you can get them as E or Z, and then I'll go through them. You'll need a periodic table because you'll have to assign priority based on atomic number. So the first one, top left, you've got fluorine and bromine on the left-hand side. Now, bromine is the high priority because it's heavier than fluorine. It's got a higher atomic number. And then on the right-hand side, you've got hydrogen versus carbon. You don't add the groups together, you just look to the first atom that it's connected to. The carbon is high priority over the hydrogen, so that's number 1. Hydrogen would be number 2, and therefore this is the Z isomer. Look at the right hand side, top right. You've got an OH group and you've got an NO2 group. Then you go to your periodic table and you see that oxygen is high priority over nitrogen because it's heavier, so this is number 1 and this is number 2. Then you go over to this side and you're looking at chlorine versus iodine, and the iodine is high priority because it's heavier, higher atomic number, and chlorine is low priority, and therefore once again they're on the same side, on this same side, so it's Z. Bottom left, you've got carbon versus fluorine. Well, fluorine is high priority, heavier, so number 1, carbon is number 2. Now on the right hand side it's a bit harder. You've got carbon versus carbon. They're both the same, so you have to go to the next carbon over here. Well, this one doesn't have another carbon and this one does, and therefore this becomes your high priority group and this becomes your low priority group. In which case the high priority groups are opposite, so it's the E isomer. And then just one more. You've got bromine versus fluorine. Well, bromine's high priority, so fluorine is low priority. And then hydrogen and CH3, well, carbon is high priority, hydrogen is low priority. And therefore this is the E isomer. Okay. And if you look at these two here, you can see that they are EZ isomers of each other. They are almost identical, except for the fluorine and the bromine have swapped around, and therefore it has two possible isomers, the E or the Z. Anyway, I hope you found that video helpful. If you did, please remember to like, subscribe, and keep checking back for more content. Take care, everyone. See you next time.